Okay, this is a corrections video for the free response projectile test if you had the tennis question. So here we have, it says at serve, a tennis player aims to hit the ball horizontally. A, what is the minimum speed that is required for the ball to clear the 0.9 meter high net about 15 meters from the server if the ball is launched from a height of 2.5 meters. Okay, the big key here is that the ball is hit horizontally. So we immediately know that Vy0 is 0, and we are looking for Vx0, since that would be the only speed that it's launched with. It has no vertical velocity because it is hit horizontally. So we're looking for Vx0. And I'm looking for Vx0, knowing that x0 is 0. X, the horizontal distance from where the ball is launched to the net, is 15 meters. I don't know how much time it takes it to get to the net. Y0 is 0, and it drops down from 2.5 meters above the ground to only 0.9 meters above the ground. So it drops down 1.6 meters. 2.5 minus 0.9 is 1.6. There's a 1.6 meter difference. And because it didn't go up 1.6, it went down 1.6, then this negative goes into play. The vertical acceleration is negative 10 meters per second squared. And again, if it's hit horizontally, Vy0, the initial vertical velocity is 0. Okay, so to start out with, Vx0 is equal to x over t. That comes from this equation. Rearranging for Vx0, we get x divided by t. We do know x, but we don't know time. So taking a look at an equation that we can get time with, anytime something is launched horizontally, you can take equation 2 off of your equation sheet, and it compacts down to y equals 1/2 at squared. So if I rearrange this for time, it's equal to the square root of 2y over a. And if I plug this into my calculator, just want to show you the square root of 2 times y divided by a. I drop the negatives because they're going to cancel out anyway. I get this for my time. And so I rounded my time to 0.6. So then I took my time back up here. My x divided by my t gave me 25 meters per second. That is an acceptable answer. I also accepted up to 26.5. And the reason there's such a difference here, if I took what I have here and substituted this equation in for time, if I did an equation substitution, so I'm not rounding here at the time, it looks like this. I have my x divided by the square roots, parentheses open. I accidentally got an extra set of parentheses here. 2 times y divided by a, parentheses closed. And when I don't do rounding myself, but I do an equation substitution, you get 26.5. So I accepted both answers there. Okay, for part B, the question is, where will the ball land if it just clears the net? Where will the ball land if it just clears the net? So we know that Vx0 around 25 or 26.5, we know that is the velocity it's going to be hit with to just clear the net. So now the question is, where will it land on the other side of the net? So I'm looking for x now, and it's no longer 15. It's going to be something greater than 15. My x0 is 0. My y0 is 0. I don't know what my x is, but this time, instead of y being negative 1.6, it's going to drop all the way down to the ground. So it's negative 2.5. Vx0 is about 25 meters per second, and I'm looking for time. So once again, time is equal to the square root of 2y over a, because the initial vertical velocity is 0. So just like we did up here, you can take that second equation and compact it all the way down to this, rearrange for time. Same thing here. Rearrange the second equation for time, Vy0 is 0, so I get about 0.7 seconds for my time. Now I'm looking for x, and x is equal to Vx0 times t. So now that I have my time, I can put a check mark here. So my Vx0 times my t gives me about 17.5 meters, or 2.5 meters on the other side. Okay. Just real quick, I just wonder what the difference is if we had used 26.5. So if I'd used 26.5 here, and I did an equation substitution, it would look like this. Vx0 times the square root of 2y over a. So I'm going to plug that, whoops, I'm sorry, I'm not showing y'all. If I did an equation substitution here, like I did for part A, it would be Vx0 times t, and in place of t, I'm going to do an equation substitution and put this in the place of t. So if I plug that into my calculator, and I'm using the 26.5 times the square root of 2 times 2.5 divided by 10, I get 18.7. Okay, I would get 18.7, and I accepted this answer as well. That would be 18.7 or 3.7 meters past the net. 18.7 or 3.7 meters past the net. Okay, for C, how long will it remain in the air? So this is talking about the total time, so we don't even have to do a calculation now because we just calculated that. This is the same scenario. It starts out at 0, but it ends up 2.5 meters below where it started. So when we calculated this, that was also calculating the answer to C. So about 0.7 seconds. Okay, then on D, I had to sketch a horizontal velocity as a function of time. And horizontally, there's no acceleration, no speeding up, no slowing down. So it's a positive velocity and it stays constant the whole time. No acceleration. No slope on a velocity time graph means no acceleration. For E, I have to sketch a vertical velocity as a function of time. And it has a constant negative slope because the acceleration is -10, so it should have a constant negative slope. So that represents a constant negative acceleration. And deciding where to start my line here, my initial vertical velocity, since it was only launched horizontally, its initial vertical velocity is 0. So I'm going to start my line at 0. And from that point, it accelerated in the negative direction. So it would be a constant negative slope. Okay, good luck on the test.